Hello there, and welcome to Sleepy Scientist Stories. I'm really glad you're here. Maybe you're lying in bed with the lights off. Maybe you're curled up in your favourite chair. Or maybe you're just letting the day quiet down. However you've arrived, this is a calm little corner where you can rest, let go of the noise around you, and wander gently into ideas that are too big to rush. Tonight, we're going to wonder about something strange, something that hides in plain sight every second of your life. Time. You glance at a clock and it's there. You feel it in the pace of your breath, in the sun rising and falling, in birthdays and seasons and calendars. Time is the invisible background music of everything. But what if it isn't? What if the universe could exist without it? What if underneath everything we think we know, time is not a fundamental ingredient, but just a convenient story we tell ourselves? I know it sounds impossible, and yet, some of the deepest theories in physics suggest that time might not be as real as it feels. Maybe it's more like the lines on a map. Useful, yes, but not actually drawn into the land itself. Before we sink into that idea, though, let me ask you something. What time is it where you are? Are you listening at midnight, the world around you quiet, or is it earlier? Maybe evening, maybe morning, maybe that quiet space in between. You don't need to answer out loud, just notice it for a second. Notice the hour on the clock and then notice how quickly it slips away. Time has a habit of doing that. You look once and it's here. You look again and it's gone. Which is why tonight we're going to slow it down together. Not because we can stop it, but because we can step back from it. And if this kind of quiet exploration feels good to you, if you like the feeling of resting while the universe unfolds like a soft story, feel free to give this a gentle like. Maybe even subscribe. I read every comment you leave too, especially when you share where you're listening from. I love watching those little dots appear all across the world like lights slowly coming on at night. So take a slow breath, let your shoulders settle, and imagine something simple. No ticking clocks, no sunrises, no before, no after, just a universe without time. Could such a thing make sense? At first glance, it sounds like pulling the floor out from under reality. But what if reality doesn't need that floor at all? Let's begin at the most familiar place, how you experience time right now. You wake up and the day has a shape. Morning leads to afternoon, afternoon to evening, and you walk along that path like you're on rails. One moment follows another, always forward. But physics has a different view. In the deepest laws of nature, time isn't always there in the way you expect. The equations that describe gravity, the equations that describe quantum mechanics, they don't actually need time the way we use it. They describe patterns, relationships, changes. Time is something we add in afterward because it's the only way our brains can understand it. If that feels unsettling, that's okay. You're not alone in that feeling. Even Einstein had to unlearn his own sense of time to see the universe clearly. He discovered that time isn't absolute. It stretches, it bends, it depends on where you are, how fast you move, and how strong gravity is around you. Two people can live through different amounts of time and still meet again, which means time isn't universal, it's personal. And if it's personal, maybe it isn't fundamental. Maybe it's just one of the ways the universe keeps track of change. And if that's true, then there could be a deeper reality where time isn't needed at all. Imagine that for a second. A universe that simply is, all at once. Not flowing, not moving, not ticking, just existing. Every event that has ever happened or will ever happen could simply be there like a vast landscape. You don't travel through it. You don't wait for it. You're simply in one part of it now, and later you might be in another. But the landscape itself doesn't change. This is hard to picture because every instinct you have is shaped by clocks and calendars and the way your heart beats. We live in time the way fish live in water. We don't notice it until we try to imagine being outside of it. But even if it's difficult, it's worth lingering on because some physicists think that's exactly how the universe works. And here's where it gets even stranger. When you look closely enough at the building blocks of reality, the particles and forces that make up everything you see, time doesn't seem to appear in the math. The rules don't say, this happens, then this. They just describe relationships, how one thing depends on another, how pieces fit together. Time, in that view, is something we experience because we're not seeing the whole picture. Like a person standing very close to a painting. You see brushstrokes, you see motion, but step back far enough and suddenly the motion disappears. The whole image is there at once. If this is true, then maybe the question isn't, can the universe exist without time? Maybe the better question is, does time only exist because of how we look at the universe? And if we could step back far enough, if we could see it all at once, would we find that time has been an illusion all along? This doesn't mean your watch is lying to you. Time is still useful. It still runs your day. But it might not run the universe. It might be the way your mind turns something too vast into something you can live with. And in a way, that's comforting because if the universe doesn't need time, then nothing is ever really lost. Every moment could simply exist forever, quiet and unmoving, like pages in a book that never close. But we're not there yet. We're still moving slowly through this idea. And before we drift further, it's worth looking at how our sense of time first became flexible, because there was a moment in history when time stopped being what everyone thought it was and became something much stranger. And to understand that, we have to follow Einstein back to the beginning of his insight, where space and time became one thing. And once we see what he saw, we'll be ready to ask an even deeper question. If space and time are linked, what happens if time disappears? You've probably had this happen before. You're sitting somewhere quiet, maybe staring out a window, maybe just lying still, and suddenly you realize you've stopped paying attention to the clock. Minutes, maybe hours slip past and you don't notice until something pulls you back. For a little while, time didn't matter. You weren't counting it. You weren't chasing it. You were just there. That's the strange thing about time. Most of the time it feels like a constant presence ticking forward, whether you want it to or not. But the moment you stop looking at it, it starts to loosen its grip. When you stop tracking it, time feels different, softer, less mechanical. It's almost as if you're stepping out of it. Not in any literal way, but in the way your mind experiences it. Think about how it feels when you're deeply focused on something you love. Maybe you're reading or listening to music or just watching the sky change color in the evening. Hours can pass like minutes. And then there are other moments like waiting in line or staring at a screen when you'd rather be anywhere else. And every second feels stretched to breaking. Objectively, the clock moves at the same pace, but your experience of it doesn't. That alone should tell you that time, at least the kind you live in, is not as rigid as it appears. This isn't just psychology, it's also physics in disguise. Your brain isn't wrong for feeling time stretch or compress. It's responding to the way you interact with the world. And in the deepest laws of the universe, time is slippery in much the same way. It doesn't tick in perfect unison everywhere. It bends and shifts depending on speed, gravity, and perspective. Einstein showed us that if you could ride in a spaceship moving near the speed of light, your clock would run slower compared to everyone else's. To you, everything would feel normal. But back on Earth, decades might pass while you've only lived through a few years. Now, you don't have to travel anywhere near the speed of light to feel a hint of that truth. You've already felt it when you stopped thinking about time. It didn't stop, of course, but your experience of it changed because your mind was no longer measuring it in the usual way. And that tiny shift is a clue. If time can feel different depending on how you look at it, maybe it isn't as fundamental as we think. Maybe it's something that emerges from how we notice change rather than something that exists on its own. Imagine for a moment that you could step completely outside the habit of measuring time. No clocks, no calendars. Not even a sense of before or after. You'd still be here. The world around you would still exist. The stars wouldn't vanish just because you stopped counting the seconds. The universe doesn't check a clock to keep going. It simply is. What would that feel like? It's hard to picture because everything we know is framed by time. But if you let yourself think about it slowly, it starts to sound less impossible. There's an experiment you can do without even leaving your bed. Close your eyes for a while and pay attention to nothing in particular. After a few minutes, you'll notice that you lose track of how long you've been lying there. You might think it's been 5 minutes when it's really been 20. You might think it's been an hour when it's been 10. That's because your brain needs reference points, events, changes, markers to know that time has passed. When those markers fade, so does your sense of time. Without motion, without difference, time slips out of focus. And in physics, that's exactly how many scientists think time itself may work. Some theories suggest that time is nothing more than a way to track change. Hello there, and welcome to Sleepy Scientist Stories. I'm really glad you're here. Maybe you're lying in bed with the lights off. Maybe you're curled up in your favorite chair. Or maybe you're just letting the day quiet down. However you've arrived, this is a calm little corner where you can rest, let go of the noise around you, and wander gently into ideas that are too big to rush. Tonight, we're going to wonder about something strange, something that hides in plain sight every second of your life. Time. You glance at a clock and it's there. You feel it in the pace of your breath, in the sun rising and falling, in birthdays and seasons and calendars. Time is the invisible background music of everything. But what if it isn't? What if the universe could exist without it? What if underneath everything we think we know, time is not a fundamental ingredient, but just a convenient story we tell ourselves? I know it sounds impossible, and yet some of the deepest theories in physics suggest that time might not be as real as it feels. Maybe it's more like the lines on a map. Useful, yes, but not actually drawn into the land itself. Before we sink into that idea, though, let me ask you something. What time is it where you are? Are you listening at midnight, the world around you quiet? Or is it earlier? Maybe evening, maybe morning, maybe that quiet space in between. You don't need to answer out loud. Just notice it for a second. Notice the hour on the clock and then notice how quickly it slips away. Time has a habit of doing that. You look once and it's here. You look again and it's gone. Which is why tonight we're going to slow it down together. Not because we can stop it, but because we can step back from it. And if this kind of quiet exploration feels good to you, if you like the feeling of resting while the universe unfolds like a soft story, feel free to give this a gentle like, maybe even subscribe. I read every comment you leave too, especially when you share where you're listening from. I love watching those little dots appear all across the world like lights slowly coming on at night. So take a slow breath, let your shoulders settle, and imagine something simple. No ticking clocks, no sunrises, no before, no after, just a universe without time. Could such a thing make sense? At first glance, it sounds like pulling the floor out from under reality. But what if reality doesn't need that floor at all? Let's begin at the most familiar place. How you experience time right now. You wake up, and the day has a shape. Morning leads to afternoon, afternoon to evening. And you walk along that path like you're on rails. One moment follows another, always forward. But physics has a different view. In the deepest laws of nature, time isn't always there in the way you expect. The equations that describe gravity, the equations that describe quantum mechanics, they don't actually need time the way we use it. They describe patterns, relationships, changes. Time is something we add in afterward because it's the only way our brains can understand it. If that feels unsettling, that's okay. You're not alone in that feeling. Even Einstein had to unlearn his own sense of time to see the universe clearly. He discovered that time isn't absolute. It stretches, it bends, it depends on where you are, how fast you move, and how strong gravity is around you. Two people can live through different amounts of time and still meet again, which means time isn't universal, it's personal. And if it's personal, maybe it isn't fundamental. Maybe it's just one of the ways the universe keeps track of change. And if that's true, then there could be a deeper reality where time isn't needed at all. Imagine that for a second. A universe that simply is all at once. Not flowing, not moving, not ticking, just existing. Every event that has ever happened or will ever happen could simply be there like a vast landscape. You don't travel through it. You don't wait for it. You're simply in one part of it now, and later you might be in another. But the landscape itself doesn't change. This is hard to picture because every instinct you have is shaped by clocks and calendars and the way your heart beats. We live in time the way fish live in water. We don't notice it until we try to imagine being outside of it. But even if it's difficult, it's worth lingering on because some physicists think that's exactly how the universe works. And here's where it gets even stranger. When you look closely enough at the building blocks of reality, the particles and forces that make up everything you see, Time doesn't seem to appear in the math. The rules don't say this happens, then this. They just describe relationships, how one thing depends on another, how pieces fit together. Time, in that view, is something we experience because we're not seeing the whole picture. Like a person standing very close to a painting, you see brushstrokes, you see motion, but step back far enough and suddenly the motion disappears. The whole image is there at once. If this is true, then maybe the question isn't, can the universe exist without time? Maybe the better question is, does time only exist because of how we look at the universe? And if we could step back far enough, if we could see it all at once, would we find that time has been an illusion all along? This doesn't mean your watch is lying to you. Time is still useful. It still runs your day. But it might not run the universe. It might be the way your mind turns something too vast into something you can live with. And in a way, that's comforting, because if the universe doesn't need time, then nothing is ever really lost. Every moment could simply exist forever, quiet and unmoving, like pages in a book that never close. But we're not there yet. We're still moving slowly through this idea, and before we drift further, it's worth looking at how our sense of time first became flexible, because there was a moment in history when time stopped being what everyone thought it was and became something much stranger. And to understand that, we have to follow Einstein back to the beginning of his insight, where space and time became one thing. And once we see what he saw, we'll be ready to ask an even deeper question. If space and time are linked, what happens if time disappears? You've probably had this happen before. You're sitting somewhere quiet, maybe staring out a window, maybe just lying still, and suddenly you realize you've stopped paying attention to the clock. Minutes, maybe hours slip past, and you don't notice until something pulls you back. For a little while, time didn't matter. You weren't counting it. You weren't chasing it. You were just there. That's the strange thing about time. Most of the time, it feels like a constant presence ticking forward, whether you want it to or not. But the moment you stop looking at it, it starts to loosen its grip. When you stop tracking it, time feels different, softer, less mechanical. It's almost as if you're stepping out of it, not in any literal way, but in the way your mind experiences it. Think about how it feels when you're deeply focused on something you love. Maybe you're reading or listening to music or just watching the sky change color in the evening. Hours can pass like minutes. And then there are other moments like waiting in line or staring at a screen when you'd rather be anywhere else, and every second feels stretched to breaking. Objectively, the clock moves at the same pace, but your experience of it doesn't. That alone should tell you that time, at least the kind you live in, is not as rigid as it appears. This isn't just psychology, it's also physics in disguise. Your brain isn't wrong for feeling time stretch or compress. It's responding to the way you interact with the world, and in the deepest laws of the universe, time is slippery in much the same way. It doesn't tick in perfect unison everywhere. It bends and shifts depending on speed, gravity, and perspective. Einstein showed us that if you could ride in a spaceship moving near the speed of light, your clock would run slower compared to everyone else's. To you, everything would feel normal. But back on Earth, decades might pass while you've only lived through a few years. Now, you don't have to travel anywhere near the speed of light to feel a hint of that truth. You've already felt it when you stopped thinking about time. It didn't stop, of course, but your experience of it changed because your mind was no longer measuring it in the usual way. And that tiny shift is a clue. If time can feel different depending on how you look at it, maybe it isn't as fundamental as we think. Maybe it's something that emerges from how we notice change, rather than something that exists on its own. Imagine for a moment that you could step completely outside the habit of measuring time. No clocks, no calendars, not even a sense of before or after. You'd still be here. The world around you would still exist. The stars wouldn't vanish just because you stopped counting the seconds. The universe doesn't check a clock to keep going. It simply is. What would that feel like? It's hard to picture because everything we know is framed by time. But if you let yourself think about it slowly, it starts to sound less impossible. There's an experiment you can do without even leaving your bed. Close your eyes for a while and pay attention to nothing in particular. After a few minutes, you'll notice that you lose track of how long you've been lying there. You might think it's been 5 minutes when it's really been 20. You might think it's been an hour when it's been 10. That's because your brain needs reference points, events, changes, markers to know that time has passed. When those markers fade, so does your sense of time. Without motion, without difference, time slips out of focus. And in physics, that's exactly how many scientists think time itself may work. Some theories suggest that time is nothing more than a way to track change. If nothing changed anywhere in the universe, if every particle stayed perfectly still, every star frozen, every atom unmoving, there would be no way to tell that time was passing. Time and change might be two sides of the same thing. Take away change and time might simply vanish. That's a strange idea, but it has consequences. It means that maybe time doesn't flow at all. Maybe it's our minds that flow, moving from one state to another, stitching together a sense of motion through a universe that is already there in its entirety. Some physicists call this the block universe, where the past, present, and future are all equally real, all coexisting in a single vast structure. We just experience it slice by slice, like flipping through the pages of a book one at a time instead of seeing the whole story at once. And when you stop thinking about time, you almost get a glimpse of that. You stop flipping the pages quite so forcefully. You rest. You let the moments blur together. It's not that time goes away. It's that your awareness loosens its grip on it. And in that loosening, you come closer to what the universe might actually be doing. There's a quiet comfort in that thought. You don't have to control time. You don't have to rush to catch it or hold it still. When you stop trying to pin it down, it softens, and you can almost feel the space beneath it. That space, the underlying reality, doesn't care if you're counting seconds. It's there whether you measure it or not. And maybe that's the first step to understanding how a universe could exist without time. You don't have to imagine everything suddenly stopping. You just have to imagine that time was never the engine running the show in the first place. Maybe it's more like the shadow of something else, something deeper. We're going to keep pulling on that thread. But before we do, think about this. The next time you look at a clock, remember that it isn't telling you what time is. It's only telling you what time looks like to a creature who has to move through it one moment at a time. If you could step back far enough, the clock might not be needed at all. And once you start to see it that way, you can begin to ask the next question. If time really isn't as real as it feels, what is it? And if the universe doesn't actually run on it, then what does it run on? If you've ever stared at a clock long enough, you know how convincing it can be. The steady tick, the orderly movement of the hands, the quiet certainty that 1 second follows another in perfect sequence. It feels unshakable. But that feeling is only a trick of perspective. The clock doesn't reveal time itself. It only measures change in a way that we've all agreed to call time. Think about what a clock actually does. It doesn't reach into the universe and grab hold of some cosmic thread called time. It just moves. Its gears turn. Its numbers change. Your phone display updates. And because those changes are regular, we've built our entire understanding of time around them. But that's not the same thing as proving time is a fundamental feature of reality. It only proves that we've gotten very good at tracking motion. And motion is not time. You can take a planet spinning around its star or an atom vibrating in space or the swing of a pendulum, and you can build a system to count those changes. But if nothing moved at all, no planets circling, no hands ticking, no atoms vibrating, what would be left of time? Would it still be there? Or would it vanish? Not because it was destroyed, but because it was never an independent thing to begin with. This is the unsettling part that physicists have been wrestling with for over a century. We've built our lives around clocks, but the universe doesn't seem to have one. Nowhere in the laws of physics is there a master clock, ticking away behind the scenes. Einstein's equations don't describe a flowing river of time. They describe relationships between mass and space, between energy and motion. Time only appears when we step into the picture, when we impose a way of slicing up those relationships into a sequence that makes sense to us. If that sounds abstract, there's a way to see it more clearly. Imagine watching a movie frame by frame. Each frame is a frozen picture. On its own, it doesn't move, but when you play them in sequence, your mind turns those still frames into motion. You see a story unfold even though every single frame already existed before you pressed play. Time in this view is the same kind of illusion. Every frame of the universe, the past, the present, the future, may already exist. Your mind is just watching them one after another and calling it the flow of time. Clocks then are like projectors. They don't create time. They just pace out the frames. We take their pacing as proof that time is real. But all they're really doing is giving our minds a rhythm to follow. Without that rhythm, you'd still exist. The universe would still exist and the structure of everything would remain unchanged. You just wouldn't have the same sense of moving through it. Even Einstein himself hinted at this. When his friend Michel Besso died, Einstein wrote a letter to his family saying, "For us convinced physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." He wasn't being poetic, he meant it. The math of relativity doesn't give any special privilege to now. From the universe's point of view, there is no universal clock striking a single shared moment. What's now for you might be later for someone else moving at a different speed or sitting in a stronger gravitational field. Time is local, flexible, personal. And if it's personal, maybe it isn't the backbone of reality. But if clocks don't measure something fundamental, why does time feel so inescapable? Part of the answer is how our brains are wired. Our memory links one moment to another in a continuous chain. We don't remember the future. We don't feel the past. We live in a narrow window of experience. And that window creates the illusion that we are being carried forward. The ticking clock reinforces that illusion, like a metronome guiding a song that's already written. You've probably felt this illusion slip before. Remember those moments when you were so absorbed in something that you forgot time entirely? Maybe you looked up from a conversation and were surprised to see that hours had gone by. It's not that time sped up, it's that you stopped measuring it. You stopped flipping through the frames. For a little while, you stepped out of the illusion. And this isn't just a philosophical trick. Physics points in the same direction. In quantum mechanics, the rules that govern particles at the smallest scales, time isn't fundamental. The equations that describe quantum states don't even need time to be written down. They only describe how one configuration relates to another. Time in that view is something we create when we stand back and compare those configurations. Without an observer to mark before and after, the math doesn't need time at all. It's hard to accept because it contradicts our instincts. We live by clocks. We wake up to alarms. We celebrate birthdays. We watch the hands move and believe we're moving with them. But from the universe's perspective, there may be no movement at all. Every tick of the clock might just be your way of walking through a landscape that's already there in full, unchanging, and complete. And if that's true, it leads to a question that might be even stranger. If time is an illusion, why does it have rules? Why does it only move forward for us? Why do we remember the past and not the future? Why does every broken glass stay broken and never leap back onto the counter in one piece? For most of human history, time was simple. It was the same for everyone everywhere. The sun rose, the sun set, and that rhythm was universal. It didn't matter who you were or where you stood. Time was the one thing you could count on to be steady, unshaken by the world around it. At least that's what everyone thought until a quiet clerk in a Swiss patent office began to see it differently. Einstein didn't set out to dismantle time. He was trying to solve a much smaller puzzle. Physicists of his day believed that space and time were separate things. Space was where events happened. Time was when they happened. One was a stage, the other a ticking clock. But when Einstein began to look closely at how light behaved, he noticed something that didn't fit. No matter how fast you moved, no matter how you chased it or ran from it, light always traveled at the same speed. That single fact changed everything. If the speed of light never changes, then something else has to. And what Einstein discovered was that what changes is time itself. Imagine two people standing apart. One is still, the other moving quickly. Each carries a clock. You'd expect those clocks to tick in perfect sync, but Einstein's equations showed that they wouldn't. The moving person's clock would run slower compared to the one at rest. Not broken, not malfunctioning, just slower. And it wouldn't just be the clock. Everything about that person, their heartbeat, their thoughts, their entire flow of time would slow down relative to the other. This was not a small adjustment. This was a revolution. It meant there was no single universal now shared by everyone. Time wasn't a river carrying everything forward at the same speed. It was a flexible fabric stretching and bending depending on how you moved and where you were. Two people could live side by side and experience time differently, and neither would be wrong. Einstein's insight didn't stop there. He realized that space and time weren't separate at all. They were one thing, space-time, a single connected framework. You can't change one without changing the other. Gravity, instead of being an invisible force pulling objects together, was the bending of that fabric. A massive planet or a star pressed down on space-time, and everything nearby followed the curves it created. Even time itself bent around those curves. A clock on Earth ticks slightly slower than a clock far out in space, not because the mechanism fails, but because mass has altered the passage of moments themselves. If this seems theoretical, you've already existed within this phenomenon without knowing it. Your ankles experience Earth's pull more strongly than your skull, meaning by a barely detectable margin, duration at your feet moves more slowly than duration at your head. You can't sense it, but the variance exists. This same principle becomes so powerful near a collapsed star that moments for someone positioned beside it would crawl almost to stillness compared to everywhere else in creation. What Einstein revealed was that duration isn't a constant foundation, it's woven into the fabric. And that fabric can be pulled, warped, and bent. The rhythmic beat is not an underlying pulse, it's a neighborhood pulse, one that shifts based on your position and velocity. This discovery rattled the pillars of science. If duration can shift, then it's not the unchanging universal constant we once imagined. It's an aspect of how reality organizes itself, a characteristic of the architecture of space-time. And if it's merely an aspect, then perhaps it's not genuinely fundamental whatsoever. More puzzling still, Einstein's formulas don't require duration to advance. They don't portray a cosmos that develops the way we envision it. Rather, they portray a framework that simply exists. History, present, and futurity are all spread out in that framework, like a blueprint. You don't need a timepiece to chart the entire blueprint. You only need a timepiece if you're traversing it one position at a time, witnessing it from within. This explains why many scientists now believe that duration, at least as we perceive it, might be a derived phenomenon. From a broader perspective, the cosmos could be eternal, a finished totality where what we label yesterday, today, and tomorrow all coexist. Your awareness just travels through it in one direction, and that movement generates the sensation of moments advancing. It's a revolutionary concept, but it matches the mathematics. And the further researchers have journeyed from relativity to quantum mechanics, the more peculiar it has grown. Some models even propose that at the deepest fundamental layer, duration might vanish completely, not because it disappears, but because it was never truly present to start with. But before we reach that point, there's something we must grasp. If duration isn't fundamental, why does it feel so inescapable? Why does it appear to have a direction, always advancing forward and never backward? If you've ever watched a stream, you recognize how constant it appears. Water moves past and you can almost persuade yourself it has no alternative. That's how duration feels most often. One instant follows another, one moment leads into the next, and you never question whether it could behave differently. But in the cryptic vocabulary of physics, the stream doesn't always flow at identical velocity. Sometimes in the silent depths of space it slows almost to stillness. This isn't metaphorical, it's among the most verified effects in science. Duration doesn't tick identically everywhere. If you carry a chronometer to a mountaintop and leave another at ocean level, the summit one will run slightly quicker. You won't detect it in any usual way. Your existence won't suddenly accelerate if you dwell at elevation. But if you examine those chronometers precisely enough, the distinction is genuine. Duration itself moves at two slightly different velocities, and if you amplify that effect sufficiently, it becomes undeniable. Picture floating near a collapsed star. From a distance, someone observing you would see your motion decelerate, your words would stretch into quiet, your chronometer would nearly halt. To you, everything would seem perfectly ordinary. You'd observe your own limbs moving, your own breathing rising and falling. But in the external cosmos, centuries would elapse in what felt to you like moments. This is what we term temporal dilation. It isn't a trick produced by your consciousness, it's embedded in reality's structure. Einstein's formulas predicted it and studies have confirmed it. Space travelers on the orbital station age a tiny portion of a second less than people on Earth because of their velocity. Navigation satellites must compensate for temporal dilation, or their transmissions would drift and malfunction. Even your device relies on an adjustment that quietly acknowledges duration is not absolute. If duration can stretch like this, then it's not the steady background we picture. It's more like a quality of the cosmos that flexes and adjusts. And when you truly consider that, something unusual occurs. You begin to understand that the cosmos doesn't experience duration the way you do. It doesn't possess a single shared chronometer ticking in harmony. It contains countless local rhythms, each one connected to velocity and mass, each one its own small stream. Stand beside a collapsed star and your stream slows. Float out into vacant space and it accelerates. The cosmos holds all of these streams simultaneously, each flowing at its own rate, and yet they coexist flawlessly. No conflict, no paradox, just a quiet, hidden adaptability. That adaptability carries a tranquility to it, because if duration can run at different velocities, then your personal present is just one of infinite ways the cosmos measures itself. It's not the universal now, it's simply yours. Someone else, somewhere else moving differently or feeling the influence of different masses living through a completely different stretch of duration. And both of you are correct. There's something almost serene about that. You're not competing against a single universal chronometer. You're moving through your own, and even that chronometer isn't rigid. It can be stretched, slowed, altered by the weight of space itself. In the deepest regions of the cosmos, duration practically grinds to a halt. Near the boundary of a collapsed star, an instant for you could endure eternally compared to the rest of the cosmos. If that's achievable, then the notion of duration as an unstoppable stream starts to appear less definite. Perhaps it's not one stream at all. Perhaps it's a web of currents, each one winding and curving depending on where it flows. And if that's accurate, then it's simpler to envision a reality where the currents disappear altogether, where the channel is empty, but the terrain, the cosmos itself, remains. This is where concepts begin to converge. If duration can slow almost to nothing near a collapsed star, then there must be locations or conditions where it doesn't exist whatsoever. Some scientists believe this is precisely what occurs at the deepest layer of reality. Duration emerges only in specific circumstances. The way heat only makes sense when you're discussing countless atoms moving together. For a single atom, heat doesn't exist. For the cosmos at its most fundamental layer, maybe duration doesn't either. But before we arrive there, it's valuable to pause to consider what this means for how we perceive the world. Every occasion you glance at a chronometer, you're seeing just one version of duration's flow. Every occasion you wait for something, you're relying on a sense of duration that is only local, only yours. Beyond that, in the larger cosmos, the stream curves in ways you can't detect. It slows, it accelerates, and in some locations it nearly stops. And if duration can pause even in that hidden manner, then it's not difficult to take the next step. What if it could disappear completely? If you think of your existence as a chain of instances, it feels natural to picture each one being created and then disappearing as the next arrives. But what if none of those instances actually go anywhere? What if every single one of them simply exists, fixed, unchanging, always there, whether you notice it or not? This is among the most unusual ideas to emerge from modern physics, but it's a serious one. In the deepest theories of the cosmos, there are no equations that say this instance becomes the next. The mathematics doesn't speak in terms of flow or motion. Instead, it describes structures, relationships between occurrences, patterns that simply are. In that picture, what you call now is just one location in a vast landscape of instances. The past isn't gone. The future isn't waiting. They all exist at once, side by side, woven into a single eternal reality. This isn't an easy thought to sit with because it's so different from how you live. You wake up, you eat breakfast, you watch the sky shift from morning to night. It feels like movement. But that movement might not belong to the cosmos. It might belong only to you, the observer, walking through a static structure, like someone reading one page of a book at a time without realizing the rest of the pages are already there. Scientists sometimes call this the block cosmos. Imagine all of duration laid out like a chart. Every point on that chart, every occurrence, every instance already exists. You don't see the entire chart because your consciousness can only stand in one place at a time. You call that place now, but the rest of the chart is no less real. You've just not reached it yet. This view comes directly from Einstein's theory of relativity. In his equations, there's no master chronometer ticking away in the background. There are only relationships between occurrences in space-time. Your now is different from someone else's now, and there's no cosmic arbiter declaring which one is the true present. That means the cosmos doesn't favor this instant over any other. All instances exist equally, even the ones you think of as long gone or yet to come. If this feels disturbing, you're not alone. It seems to eliminate the distinction between past, present, and future, but it also resolves a puzzle. If duration were truly flowing, where would it be flowing from, and where would it be flowing to? If the future doesn't exist yet, how could you ever reach it? And if the past no longer exists, why can you recall it so clearly? The block cosmos sidesteps all of that. Nothing flows, nothing disappears, nothing begins or ends. It just is. Now, you might wonder, if every instance exists, why don't we experience them all at once? The answer may lie in how our minds work. Your brain weaves together a sequence of occurrences to create a narrative. Because without that narrative, you couldn't function. You'd be overwhelmed by a reality that contains everything at once. Instead, you experience a single slice at a time, and that slice feels like the present. From that perspective, duration is less like a stream and more like a beam slowly scanning across a stage that was already constructed in its entirety. There are even studies that hint at this hidden eternality. In quantum theory, particles don't appear to have fixed locations or trajectories until we observe them. Between those observations, the mathematics that characterizes them contains no mention of duration. The cosmos at its most basic layer might not be progressing. It might simply exist as a web of potential conditions, all linked with duration, appearing only when you step back sufficiently to perceive the arrangement your consciousness anticipates. If that's accurate, then every instant, this one included, might be eternal. When you smile at humor, when you take your initial stride, when you gaze up at the cosmos for the very first occasion, those instants don't dissolve into emptiness. They persist. You've only departed from them. This perspective of the cosmos doesn't render duration meaningless. It simply transforms what duration is. Rather than a power pushing you ahead, it becomes a method of traversing a terrain that's already present. The past doesn't vanish. The future isn't expecting. You're simply stepping from one fixed instant to the next. And if that's the situation, it raises a question that's even more fascinating. If duration is a mirage created by moving through these motionless instants, what occurs if you could step outside of that movement entirely? What would you observe if you could pause and examine the whole framework at once? Not just one instant, but all of them. When you contemplate the cosmos expanding, it's natural to envision galaxies racing through space as if they were sprinting across a platform. But that's not what's occurring. Space itself is extending. The galaxies aren't flying apart because they're moving through some vacant vessel. The vessel itself is enlarging. Distances broaden. Not because things are journeying, but because the very fabric of reality is unfurling beneath them. This concept alone is peculiar enough, but it leads to an even deeper inquiry. If space can extend, can duration be left behind? We tend to connect the two so tightly that it's almost impossible to divide them. Einstein's work bound space and duration together into one single entity, space-time, where alterations in one influence the other. When mass warps space-time, it warps both space and duration. When you move quicker through space, you move slower through duration. They are interwoven, inseparable in the way we usually picture the world. And yet, the cosmos seems to follow rules that don't always match our intuition. Space can expand. We've observed it occur. Distant galaxies drift farther and farther from us, not because they are moving through space, but because there's more space between us. And this expansion doesn't require anything to happen to duration itself, at least not in the way we experience it. Duration doesn't visibly extend when the cosmos grows. Your seconds don't get longer just because a galaxy billions of light years away is receding faster than you can envision. This suggests something subtle but powerful. Space and duration are bound together, but not always in the way we think. Space can evolve, grow, change in magnitude, while duration seems to be something we experience locally in the middle of it all, as if we're standing still while the cosmic fabric extends around us. Now imagine taking that to its limit. What if the cosmos could exist without duration altogether? What if what we call duration is only a local quality? The way heat only exists when many particles move together. A single particle doesn't have heat. It has energy, yes, but heat is a term that emerges when enough pieces interact. Maybe duration works the same way. Maybe it isn't fundamental. Maybe it's something that only appears when matter and energy arrange themselves in certain ways. There are theories in physics that treat duration exactly like this. In some approaches to quantum gravity, the attempt to unite quantum mechanics with Einstein's space-time, duration disappears from the equations entirely. What's left is a description of the cosmos in terms of relationships, not motion. Things don't happen in sequence. They just exist in relation to one another. The before and after that you and I depend on aren't there, and if those theories are correct, then duration is something like a shadow cast by space and matter. When the cosmos is dense and structured, the shadow looks clear and steady, but if you were to peel it back to its simplest, most fundamental state, the shadow would vanish, and with it, duration. Space would still exist, stretched, curved, and structured, but without the ticking chronometer we experience inside it. This might sound like a contradiction. How can space expand if there's no duration to expand into? But that question only exists because of the way we're used to thinking about change. In a timeless cosmos, expansion wouldn't be something that happens. It would simply be part of the cosmos's structure. The cosmos wouldn't grow. It would simply be large with that size built into its very nature. And what we see as growth would only be our way of walking through that structure one slice at a time. This is hard to picture, but not impossible. When you look at a chart, you don't see a path getting longer as you trace it with your finger. The path was always that length, you're just following it. In the same way, space might not be stretching in duration. It might simply be what it is, and duration is nothing more than the way we experience our journey across it. If this is true, then it brings us closer to something remarkable, a cosmos where duration is not the stage, but a perspective, not a thing that exists on its own, but a way of looking at something deeper. When we talk about the cosmos, we almost always talk about it in terms of origins. We picture an instant when everything started, a moment when the first light appeared, when duration itself began to tick. The Big Bang is the story we're told, and in many ways, it's the best story we have. But what if it isn't the complete story? What if the cosmos didn't begin at all? It's a strange concept because our minds are built on sequences. You wake up, then you eat, then you move through your day. One thing follows another, and you can't help but imagine the same is true for everything, even the cosmos. If there's a now, then surely there must have been a before. But the laws of physics don't share that intuition. They don't need an origin. In some of the deepest theories we have, the cosmos doesn't start. It simply is. The Big Bang in this view wasn't the first instant of duration. It was just one feature in a much larger structure. Duration as we experience it might emerge only inside certain conditions. Conditions that didn't exist before the cosmos cooled and expanded enough for chronometers, change, and sequences to make sense. Outside of that, there may be no before and no after. This isn't just speculation. In quantum cosmology, there are models where the cosmos is eternal. All of space, all of energy, all of the instants you could ever point to exist in a single unified whole. We only perceive an origin because we are trapped inside one thin slice of it. From our narrow perspective, the Big Bang looks like the start. From outside, it might simply be one region in a much larger chart. No more the beginning than the middle of a circle is its start. Even Einstein hinted at this in his later work. He imagined a static cosmos, one that didn't require duration to move forward in order to exist. Though his version of the cosmos was later replaced by the expanding cosmos we now accept, the idea that the cosmos might not need a true origin never disappeared. Modern physics keeps circling back to it, because every time we peel back another layer of reality, duration itself starts to fade from the picture. And if there was no origin, there may also be no conclusion. Heat death, the collapse of stars, the fading of galaxies, all of these things might happen within the slice of reality we see. But in the larger structure, the one that contains every instant equally, nothing is ever truly lost. Every star that burns out still exists in its own place. Every instant in your life remains. The cosmos isn't erasing them. You're just walking past them. This view changes everything. It means the question, what happened before the cosmos, might be meaningless. Not because there's no answer, but because before doesn't exist at the fundamental level. It's like asking, what's north of the North Pole? The question dissolves when you see the whole shape. If that's true, then maybe the cosmos doesn't need duration to explain itself. Maybe duration is only a way for us to navigate what was always there. And if that's the case, then the Big Bang was not an origin. It was simply the point where the part of the cosmos we inhabit became visible to us. This way of thinking might feel unsettling, but it's also strangely calming. If there was no true origin, and there will be no final conclusion, then the cosmos is not rushing toward anything or away from anything. It is simply there, complete, unchanging in its totality while we move through it. But there's still a question left hanging in the air. If the cosmos is eternal in this deep sense, how do we explain the way we feel duration moving? Why do we remember yesterday but not tomorrow? What gives duration its direction, if not some cosmic chronometer? If you've ever watched a chronometer in a quiet room, you can almost hear it speaking. Each tick is small, precise, certain. But in the world of the quantum, that certainty disappears. Duration itself seems to lose its voice there. It doesn't tick. It doesn't march forward. In fact, it becomes something far stranger, something that might not exist in the way we think at all. At the smallest scales of reality, the rules change. Particles don't move from point A to point B like little spheres on a table. They exist in clouds of possibility, spread out as if they're in many places at once until you look. And here's the part that unsettles everything. The equations that describe this quantum world don't need duration. They don't say, first this happens, then this. They describe relationships static and eternal. One of the most striking examples is the Wheeler-DeWitt equation, an attempt to bring quantum mechanics and general relativity together. It has no duration variable at all. None. It treats the cosmos as if every possible state already exists simultaneously. And what we call duration is just a way of looking at it from inside, not a quality of the cosmos itself. In this view, the flow of duration is like a narrative we tell ourselves. Consider the experience of reading a novel. You turn each page, discovering what happens next, but the entire story already exists within the book's covers. Your journey through the narrative doesn't alter the plot. It merely reveals what was always there. Some interpretations of quantum mechanics propose that reality operates similarly. The universe exists as a complete unchanging structure, and what we perceive as time's passage is simply our consciousness moving through different sections of this eternal whole. This concept isn't purely philosophical speculation. Quantum entanglement provides compelling evidence. When two particles become entangled and are separated across vast cosmic distances, measuring one instantly affects the other, regardless of the space between them. This phenomenon doesn't involve faster-than-light communication. Instead, it suggests that both particles exist within a unified, timeless framework where concepts like before and after become meaningless. They don't respond to each other across time and space. They simply exist as parts of an eternal, interconnected system. This evidence leads some physicists to conclude that time lacks fundamental reality. Like temperature emerging from countless molecular collisions, time might arise only when we observe reality from a sufficiently broad perspective. At quantum scales, time could dissolve entirely, leaving behind pure, unstructured existence. The familiar rhythm of temporal flow appears only when we step back far enough for the world to seem recognizable and ordered. This revelation feels profoundly unsettling, yet it aligns with our deepest discoveries. Each layer of investigation reveals time slipping further from our grasp. Classical physics presented time as an unchanging stage for cosmic events. Einstein demonstrated its malleability, how it could stretch and compress. Now quantum mechanics suggests that at reality's foundation, time might be entirely absent. What we experience could be merely the shadow cast by our interaction with an underlying timeless architecture. Yet, this raises a crucial puzzle. If time vanishes at quantum levels, why does it manifest so convincingly in everyday experience? Why does existence appear so systematically ordered, with clear sequences of cause and effect, memories of the past, and anticipations of an unknowable future? The answer lies in understanding the boundary between quantum reality and our observable universe. Somewhere in the transition between these realms, time reemerges, not as an intrinsic property of the cosmos, but as a pattern that crystallizes when sufficient particles, interactions, and complexity accumulate to create a sense of sequence. Time doesn't generate change, rather change generates time. If this is accurate, then time serves merely as a cognitive tool we use to comprehend a universe that functions perfectly without it. Reality already exists in its complete form beneath everything we perceive. This understanding leads us to examine the universe's most extreme environments, where time's apparent solidity crumbles entirely. Black holes represent natural laboratories where time's fragility becomes undeniable. These cosmic enigmas don't merely distort space, they stretch time until it nearly vanishes. Picture yourself approaching a black hole. An external observer would witness your gradual deceleration. Your movements would become increasingly sluggish. Your timepiece would slow dramatically. Upon reaching the event horizon, you would appear frozen from the outside perspective, trapped eternally in a single extended moment. Yet from your viewpoint, nothing unusual would occur. You would continue falling, crossing the boundary, unaware that time had stopped. The external universe would seem to accelerate dramatically around you. This paradox reveals time's subjective nature. Black holes split reality into equally valid but contradictory perspectives. Time becomes so flexible that the concept loses coherent meaning. The strangeness intensifies beyond the event horizon, where space and time exchange roles. Forward temporal movement becomes as inevitable as gravitational descent toward the center. You cannot resist this progression or reverse direction. Time ceases to be an experience and becomes instead a one-way pathway you cannot escape. For physicists, this represents more than mere curiosity. It's a fundamental clue. Black holes push Einstein's flexible time to its ultimate limits. If time can halt at a black hole's edge, perhaps it was never truly fundamental. Perhaps these objects reveal the universe's underlying skeleton, regions where time dissolves to expose something deeper that requires no temporal foundation. The event horizon itself deepens this mystery. It's not a physical surface, but a boundary defined by spacetime's geometry. Cross it, and no information can ever return. Yet for distant observers, this boundary appears as time's absolute edge, a place where moments accumulate without advancing. Standing there, you would witness the final instant of anything that fell in, suspended in perpetual stasis. Beyond that threshold lies uncertainty. General relativity predicts a central singularity where our understanding collapses. Quantum physics suggests no singularity exists, only a different kind of timeless region where space and time become meaningless concepts. Some scientists propose that black hole interiors hold keys to understanding existence itself. Explaining why time breaks down there might reveal why it exists anywhere else. Black holes thus transcend cosmic curiosities to become natural laboratories for physics' deepest questions. They demonstrate what occurs when time reaches existence's boundaries. In their profound silence, they may be revealing that the universe needs no time to be what it is. But black holes aren't time's only vanishing points. In the earliest moments following the Big Bang, in quantum reality's fundamental fabric, the same pattern emerges repeatedly. Time is neither fixed nor universal. Under extreme conditions, it might not exist at all. This leads to a startling conclusion. Time might only be a convenient narrative applicable to our specific scale and conditions. Step outside these parameters, whether at a black hole's edge or reality's foundation, and the story dissolves. This raises profound questions about our nature. If timeless regions exist within the universe, perhaps time isn't the rule but the exception. If so, we must ask what reality looks like when we stop treating time as existence's organizing principle. Imagine rewinding the universe beyond the first stars and atoms to the very beginning. You might expect time to accelerate, counting down to creation's first instant. But what if instead of accelerating, it simply stopped? What if at the earliest stage, before the universe began its expansion, no time existed at all? This isn't mere speculation. Advanced physical theories suggest the early universe wasn't just compressed and energetic. It was genuinely timeless. Equations describing the universe at its smallest pre-expansion scales contain no temporal variables. They describe a static quantum state, a frozen condition with no before, no after, no motion, no change. This concept has precedent in quantum mechanics, where particles don't move conventionally. They exist in superposition, multiple states simultaneously, until interaction or measurement forces a definite outcome. The universe's beginning may have resembled this, a vast, timeless superposition containing every possibility, awaiting something to break the symmetry and create what we call time. Cosmologists sometimes describe this early state as quantum foam or a universal wave function, a condition where temporal concepts don't apply. Nothing changes because there's no before or after for comparison. The universe seems to hold its breath, not yet flowing, not yet dividing into the moments we experience. Only later, as expansion and cooling began, would familiar time emerge like a pattern crystallizing from perfect stillness. Researchers compare this to temperature's emergence from particle interactions. A single particle has no temperature. Only vast collections of interacting particles make hot and cold meaningful. Similarly, the earliest universe may have lacked time until it grew sufficiently structured for change to take shape, allowing time to activate. This means asking what preceded the Big Bang might be meaningless. If time didn't exist, there was no before for events to occur within. What we consider the beginning might simply be when time first became meaningful, when a timeless state yielded to the familiar sequence governing our lives. This picture is unsettling because it eliminates the idea of a starting point. The universe doesn't explode from nothing in a single moment. Instead, it emerges smoothly from a state where nothing moved and nothing needed to move because no time existed to measure motion. If true, this reshapes our understanding of everything. Time isn't a fundamental universal feature, but a byproduct of cosmic growth. It didn't exist until there was something to measure. If it had to emerge, it could reasonably vanish again, returning to the timeless state that may have existed initially. This isn't merely abstract theory. Physicists working on quantum gravity and cosmology use these concepts to build models matching current observations. The cosmic microwave background's ripples, the Big Bang's faint afterglow, may be fingerprints of this transition from timelessness to time. If the universe began timelessly, and time emerged only as expansion occurred, this presents an extraordinary possibility. The universe doesn't require time to be real. Time is something we experience because of where and how we exist, not because it's built into everything's foundation. But if time can activate, could it also deactivate? Could regions exist even now where time is absent, as it may have been initially? Places not at the universe's edge, but hidden in reality's deep structure, where change doesn't occur and the cosmic clock falls silent. When contemplating the future, you probably imagine something open, unwritten, awaiting realization. The past seems fixed, the present is now, and the future hasn't arrived. This feels obvious. But according to one of physics' strangest and most discussed ideas, this might not reflect reality's true nature. This concept is the block universe theory. In this view, the future isn't something that happens later, it's something that already exists. Einstein's relativity theory opened the door to this revolutionary perspective. Relativity reveals that no universal now spans the cosmos. Your present moment might exist in another observer's future or past, depending on their velocity and location. This eliminates any cosmic boundary separating past from future. Every moment possesses equal reality, distributed throughout space-time like coordinates on a geographical chart. Consider a novel resting in your hands. All pages exist simultaneously. While the current page feels uniquely real, the others aren't awaiting creation. They're already present. You'll encounter them sequentially, but they don't materialize when you turn pages. They've existed from the beginning. Similarly, the block universe theory proposes that every moment, yesterday, today, tomorrow, exists simultaneously within a four-dimensional framework. You simply traverse it one instant at a time. This perspective revolutionizes temporal understanding. The future isn't empty space awaiting fulfillment. It's as concrete as the past. You simply haven't arrived there yet. While unsettling, this follows naturally from established physics. Einstein's equations identify no privileged now. Natural laws treat all temporal coordinates identically. Within this framework, time doesn't flow. No universal chronometer advances. What we interpret as temporal passage is our consciousness moving through this static structure. We don't perceive other moments because awareness can only focus on individual slices. This concept reframes memory. We recall the past not because it's vanished, but because it represents the portion of the block we've already traversed. The future seems mysterious not because it lacks existence, but because we haven't reached it. From an external perspective beyond our experience, no distinction would exist between them. Every moment would be equally real, embedded in space-time's fabric, motionless and eternal. This raises challenging questions. If the future already exists, is everything predetermined? Are choices illusory? Some physicists and philosophers argue that even if every moment is fixed within the block, the experience of decision-making remains part of the structure. The act of choosing and the sensation of freedom are as real as any other event. The block doesn't eliminate it, it contains it. This worldview can disturb, but it can also console. If every moment already exists, nothing is truly lost. Your happiest day, beloved people, quiet evenings you thought were gone, they remain woven into the universe's structure. You've merely moved past them, but they endure. If true, the same applies to the future. Somewhere in the block, every step you'll take is already part of the whole. You needn't worry about capturing it. It's already there, awaiting your arrival. Yet a deeper mystery lurks within this idea. If time is merely the block's dimension, and all moments exist simultaneously, why do we move through it unidirectionally? Why don't we experience the future like we experience the past? Why does time, even in a timeless universe, still seem to have an arrow pointing forward? If the universe is a vast block of moments, each already present, why does your life feel mobile? Why do you sense yourself changing, aging, and living through time, rather than simply existing within it? The answer may be that you don't inhabit just one type of time, you inhabit two. The first is cosmic time, physics time, measured by atomic clocks and space-time curvature. This is the time satellites depend on, GPS systems must adjust for, and astronomers use to track galaxies billions of light-years distant. It's objective, impersonal, and governed by relativistic laws. The second is biological time, the time your body carries. You feel it in your heartbeat, breathing rhythm, and sleep cycles. It exists in your cells' gradual changes and your body's subtle daily tracking without external clocks. Unlike cosmic time, biological time is intensely personal, connected to memory, perception, and the physical processes defining your identity. These temporal types don't always align. In cosmic time, you might hurtle through space at tremendous velocities unnoticed. In biological time, moments of fear or joy can extend indefinitely, while boring hours feel eternal. Your body's time is elastic, bound not to relativity's precise equations, but to your lived experience. More intriguingly, cosmic and biological time interact subtly. International Space Station astronauts experience time marginally slower than Earth dwellers due to their speed and spatial position. Their bodies age imperceptibly differently than ours. They inhabit slightly different cosmic time slices, while their biological clocks continue their familiar rhythm. Regardless of location or velocity, your body's time remains grounded in consistent patterns. You sleep, wake, age. Your brain weaves these changes into narrative, creating the sense of forward movement through a universe that from a broader perspective might be stationary. Biological time generates the arrow of time's reality. This arrow isn't inscribed in physical laws. Relativity's equations function equally well in reverse. But your body, like all matter, is bound to entropy. The universe's gradual disorder increase. This explains why you remember the past but not the future, why broken objects don't spontaneously repair themselves. Your biology is a unidirectional process unfolding within a universe that at its deepest level might be timeless. Viewed this way, your strong temporal sense becomes understandable. It's not merely clock ticking, it's the sum of your body's activities, from cellular growth to your brain weaving moments into memory. Without this biological layer, you might not feel time's passage at all. You'd simply exist like everything else in the block universe without noticing your motion. This dual existence, cosmic time on one side, biological time on the other, creates fascinating tension. While the universe may be holistically timeless, your personal experience is entirely built around change. You inhabit the picture's moving part, even if the larger picture never moves. This might explain why time feels precious. It isn't a fundamental universal feature, it's your feature. You carry it everywhere and it shapes how you perceive everything else. But there's another layer. If your body can experience time differently from the universe, what happens in the one place where your temporal sense naturally fades almost completely, where minutes and hours blur and the clock's ticking loses its grip? That place isn't in deep space or at a black hole's edge. It's much closer, the world you enter every night when you sleep. Each night without consideration, you enter a world where time nearly stops. You close your eyes and the familiar rhythm of seconds and minutes dissolves. Hours pass unnoticed. You might dream, and in those dreams, complete stories unfold. Yet upon waking, you cannot determine how long anything lasted. This is how your brain escapes time in sleep. Sleep isn't merely rest. It's a shift in reality experience. When dreaming, your brain doesn't maintain time like it does when awake. The internal clocks anchoring you to the present moment lose their hold. A dream can feel like days or seconds, with no reliable way to measure the difference. Your mind doesn't care about clock ticking. It isn't bound to cosmic or biological time similarly. It slips into something else, something approaching timelessness. This isn't merely poetic dream description. Neuroscientists have discovered that during sleep, brain networks responsible for time tracking become quiet. Mind parts that monitor duration and sequence step back. Instead, the brain focuses on weaving images, sensations, and memory fragments into something feeling continuous but unmeasured against external standards. This explains dreamtime's strangeness. You can live entire lifetimes in dreams, walk through non-existent cities, have seemingly hour-long conversations, then wake to find only minutes passed. Your brain isn't counting seconds, it's building a world where seconds don't matter. In this sense, sleep is among your closest experiences to a universe without time. You still exist, thoughts still move, but they move without the rigid before and after framework holding them in place. You don't wake mid-dream wondering about time. You only do that when returning to the waking world where clocks rule again. This nightly escape hints at something profound. If time can lose its hold on you so easily, if your brain can function in states where time is irrelevant, then maybe time isn't as essential to consciousness as it feels. Maybe it's just one perceptual mode, one way of organizing experience among many. This also explains sleep's restorative quality. For hours, you're not just resting your body, you're stepping outside time's relentless push. You're slipping into a state with no rush, no countdown, no constant clock awareness. When you wake, returning to time can feel abrupt, as though you've rejoined a current that was always there, but that you'd been floating above temporarily. Notice how similar this is to what physics tells us about time itself. Beneath the surface, in the quantum world, no ticking clock exists. Time emerges only when you zoom out sufficiently to perceive it. Your mind seems to do something similar. When dreaming, it stops tracking time at your accustomed scale. It drops to a lower level where time simply isn't pictured. But then you wake, check the clock, and without thought step back into the steady rhythm of seconds and minutes as if nothing happened. Only when you pause to consider it do you realize how strange this is, that every single night you pass through a timeless world and return without noticing the transition. Maybe this is another clue. If your mind can so easily exist without time, even for hours at a stretch, then maybe time really isn't the unshakable foundation we think it is. Maybe it's something you use, not something you are. If you've ever stood on a mountain peak gazing down at valleys below, you've felt gravity's pull in the most ordinary way. But what you might not realize is that gravity isn't just holding you in place, it's quietly altering how time passes for you. Einstein's general relativity theory revealed something extraordinary. Gravity doesn't merely curve space, it warps time itself. Stronger gravitational fields cause time to decelerate. This isn't perceptual trickery or sensory limitation, it's genuine. Living your entire existence near a massive planet's surface would make your timepiece run slower than someone's far above you, where gravity weakens. You wouldn't detect it. Your pulse would maintain its familiar rhythm. Your days would feel normally paced. Yet compared to someone distant from that gravitational influence, you would age marginally slower. Time itself would be dilated for you. We've verified this through experiments with ultra-precise atomic chronometers. Scientists have measured temporal differences between clocks separated by mere feet of elevation. The timepiece closer to Earth's surface, where gravity is slightly more intense, operates infinitesimally slower than the elevated one. The variance is minuscule, but it's there, inscribed in space-time structure. This phenomenon becomes far more pronounced near massive objects like black holes. There, gravity distorts space-time so drastically that time nearly ceases. Standing near a black hole's edge while someone else remains distant, they would observe you moving in extreme slow motion. Your minutes might equal their centuries. From their vantage point, you'd appear perpetually frozen at the threshold while the universe rushed forward. Yet from your perspective, nothing would seem abnormal. Your seconds would elapse normally. This represents one of time dilation and gravity's strangest aspects. Every observer's experience is self-contained. Nobody ever senses time decelerating for themselves. You only perceive it when observing someone else, when stepping outside your local chronometer and comparing it to another. This means no single master clock governs the universe. Only countless local times exist, each sculpted by gravity. Orbital satellite clocks run faster than terrestrial ones because they're more distant from our planet's gravitational pull. GPS systems must compensate for this, or their calculations would be hopelessly flawed. Every technology depending on precise timing is quietly reminding us that time isn't absolute. If time can stretch this way, it's difficult to continue viewing it as fundamental. A universal, unchanging flow wouldn't yield to gravity, but time does. It conforms to the universe's geometry, to space-time's curvature itself. In some locations, those curves reduce it nearly to zero. It's in those extremes, near black holes, in the early universe, deep within physics equations, that we begin understanding what might truly be occurring. Time isn't the foundation. It's a byproduct. Gravity demonstrates this clearly. As space curves, time curves with it, like a shadow shifting because something deeper moves underneath. If that's accurate, then perhaps time doesn't define reality. Perhaps it's reversed. Reality's shape defines time. When the shape changes sufficiently, time itself nearly vanishes. This realization is subtle but transformative. If time depends on gravity, then it's easy to envision a universe, or even regions within ours, where gravity's influence or absence renders time meaningless. This leads to an even stranger inquiry. If gravity can decelerate time until it nearly halts, what would living outside time altogether mean? Not theoretically, but in the way physics seems to suggest is possible in certain places at reality's edge. Attempting to imagine existence outside time immediately encounters mental barriers. We're so accustomed to measuring life in seconds, minutes, and years that picturing existence where none of those apply becomes nearly impossible. But physics keeps indicating a reality where time might not be fundamental. If true, there must be ways to at least glimpse what it would mean. Begin by removing everything you normally associate with time. No timepieces, no dawn or dusk, no aging, no before or after. What remains isn't emptiness, it's still the universe. Stars would continue existing. Matter and energy would persist. But without time, nothing would change. No motion, no causation, just a complete and motionless whole. This isn't science fiction. It's what many physics theories actually describe at the most fundamental level. In quantum gravity equations, no time variable exists. The universe is treated as a single timeless entity with every possible state existing simultaneously. In this view, time isn't something the universe possesses. It's something emerging only when observed from someone inside it. If you could step outside that perspective, you wouldn't witness events unfolding. You wouldn't see the universe happening. You'd perceive everything at once, every moment that has ever existed or will exist, coexisting like points on an enormous map. No need would exist to move from moment to moment because every moment would already be present. From our viewpoint, this is nearly inconceivable because our life experience depends entirely on change. We feel time because our bodies transform, because we retain past memories and anticipate futures. Remove those elements and what remains wouldn't resemble life at all. It would be something entirely different, a state of pure existence without any sense of passage. Yet strangely, you already encounter this concept daily. When you sleep deeply and wake with no night memory, hours pass but don't feel like they did. It's as if you jumped from one point to another without crossing the intervening space. For you, those hours didn't exist. That's not what living outside time would be like, but it's a hint. It shows how easily your mind can skip duration experience and simply be in one moment then another without feeling the movement between them. If time truly emerges rather than being fundamental, then living outside it wouldn't mean floating in darkness or nothingness. It would mean existing in a state where everything simply is. No waiting, no forward movement, no sense of loss because nothing can ever be lost if all moments exist eternally. This is why some physicists and philosophers view this idea not as frightening, but as strangely peaceful. If the universe at its deepest level is timeless, then everything that has ever occurred and everything that ever will occur is permanently woven into it. Nothing disappears. Nothing is erased. We only experience it piecemeal because that's our only possibility. But if that's true, then a new question arises. If time isn't fundamental and reality might be timeless underneath, why do we experience time as we do? Why do we live in this unidirectional flow instead of perceiving everything simultaneously? The answer might not be that time is illusory, but that it's a kind of lens, one that transforms a timeless universe into something we can inhabit. To understand that lens, we need to examine what happens if we push this idea further. What if time stopped entirely, not just for you, but for the entire universe? Would anything actually change? If time suddenly ceased, what would you expect? Perhaps you imagine everything freezing, planets halted in orbits, waves paused mid-air, every thought in every mind suspended. But if time truly stopped, there wouldn't be a moment for you to observe it. There wouldn't even be a you to notice. That's the paradox. When you remove time, change vanishes with it. Motion, memory, and causation only make sense within time. If time stopped, nothing would happen, not even the stopping. The universe wouldn't freeze. It would simply exist in a state with no before and no after. This is one reason physicists argue that time isn't a fundamental universal feature. It's not that there's a cosmic chronometer that could run out or suddenly halt. Time doesn't seem to exist independently at all. What we call time might only be our method of tracking change. Remove the changes and you don't just stop time, you eliminate any need for it. You can glimpse this idea in physics mathematics. The equations describing the universe don't require a universal ticking clock to function. They only describe relationships, how one thing depends on another, how matter and energy interact. When nothing changes in those relationships, time becomes irrelevant. It simply disappears from the picture. Even your own experience supports this in small ways. Consider moments when you've lost all time sense. Perhaps while gazing at the sky, perhaps while drifting towards sleep. Time didn't really stop, but your change awareness became so faint it almost felt like it had. In those moments, you weren't counting seconds. You were simply existing, and nothing seemed to move. This is why if time were to stop in the deepest sense, nothing would actually feel different. There would be no feeling at all. A timeless universe wouldn't be empty or dead. It would be complete. Everything would exist simultaneously, every event, every detail, but there would be no motion through it. No frame after frame, no story unfolding, just the whole all at once. This isn't mere speculation. In some physics theories, especially quantum gravity, this is exactly how the universe is described. Time doesn't appear in the equations. The universe is treated as a static object. What we call time's flow isn't something the universe is doing. It's something we experience because we're inside it. We're moving from one part of that static whole to another, and our minds translate that motion into narrative. If you removed that story, if you could step outside it, you wouldn't see time stopping. You'd see that it was never running in the first place. If that's true, then asking what happens if time stops might be like asking what happens if you turn off light in a room full of objects. The objects don't vanish. You just stop seeing them the way you used to. This isn't an ending, it's another perspective shift. Because if nothing would change if time stopped, then time might not be the foundation we've always believed it was. It might be a convenient way for us to move through something that was never moving at all. If that's the case, then we need to take one more step, because there's an idea that builds on this, one that many physicists and philosophers quietly accept. The sole possession we ever truly hold is the present moment, not because the past has vanished or the future lacks reality, but because every instant is part of one eternal now. If you've ever sat in stillness and felt a moment expand until it seemed to contain the entire world, you've touched an idea that both philosophers and physicists have pursued for centuries. The concept is elegant, only now truly exists. From physics' perspective, this emerges from relativity. No universal now exists, no single temporal slice shared across the cosmos. What you call the present depends on your location and movement. Two people in different places can disagree about what now even means, and both can be correct. This alone suggests that time's flow isn't fundamental, it's a matter of perspective. Philosophers have expressed something similar for much longer. For them, the present isn't merely a fleeting point between past and future, it's the only place anything ever occurs. You cannot inhabit the past, you cannot stand in the future. All you ever actually touch is this single continuous moment. Here's where science and philosophy quietly converge. In some interpretations of modern physics, the universe isn't flowing from one moment to the next at all. Every event, every heartbeat, every stellar ignition, every word you'll ever speak exists simultaneously, embedded in space-time's fabric. From outside it, no past or future exists, only a single eternal structure. What we call now is simply where our awareness happens to be. This doesn't mean the past is gone or the future isn't real. It means they're both as real as this instant. You simply cannot stand in all of them simultaneously. Your mind is a traveler, and the present is the path it takes. But the path already exists. You're not carving it from nothing, you're following it. Strangely, this idea isn't bleak, it's comforting. If every moment exists forever, then nothing is ever truly lost. A child's laughter, a single afternoon's warmth, stars you saw on a clear night, all of it still exists, written into the universe as unshakably as physical laws themselves. You've simply moved past those places, but they remain. If the future is also part of this eternal structure, then it's not rushing toward you like a wave you must outrun. It's already waiting. Every step you will ever take is already there, part of the whole, just as unshakable as your past. This is the eternal now. It's not a moment that passes. It's the entire universe seen all at once. Philosophers reached it through reflection. Physicists reached it through mathematics. Both perspectives meet in the same place. The realization that time as you experience it is only one way of looking at something much larger and far quieter than any clock's ticking. But there's one more step we can take. If the universe is already complete, if every moment exists in an eternal now, then perhaps you don't need to hold on to time at all. Perhaps it's enough simply to rest in it, to exist in this slice of infinity, knowing that nothing is ever lost and nothing ever truly ends. This brings us to the final thought that ties everything together, not physics, not philosophy, but the simple human way of living in a universe that doesn't need time at all. If everything we've explored is true, if time is not fundamental, if every moment already exists, if past and future are as real as the present, then we're left with a choice. Is the universe without time, or is the universe nothing but time, stretched out in its entirety, waiting to be seen? These two ideas sound opposite, but in a way, they might be identical. When physicists describe the block universe, they discuss time as if it's laid out like space, a dimension that doesn't move but simply is. From that perspective, there's no flow, no ticking clock, no universal now. But that doesn't mean there's no time at all. It means the universe might be made entirely of it, a vast structure of every moment, every change, every event existing together in one unbroken whole. If that's true, then time is not something that passes, it's something that is. The future doesn't arrive any more than a distant mountain suddenly pops into existence when you walk toward it. It was always there. You just couldn't see it yet. Yet from our perspective, this doesn't feel like a static universe. We live inside time as if it were a river. We measure it, chase it, feel it moving around us. That feeling might only be how consciousness travels through this larger structure, one point of awareness sliding along a dimension that never changes. But even if the universe is timeless at its core, time is still what we see from the inside. This is why the question isn't easy to answer. To say the universe has no time would be true from one viewpoint. But to say the universe is made of time, of every moment that ever was or will be, might be just as true from another. The difference isn't in the universe, it's in how we experience it. This brings us back to something important. If every moment already exists, then the universe is not rushing toward anything. It's already complete. You're not racing against time. You're simply walking through a reality that from a higher perspective is already finished. But for you, here, inside it, time still matters. It's what gives shape to your life, what lets you experience the story one moment at a time, instead of being overwhelmed by the entire thing at once. It's the reason you can remember yesterday and dream about tomorrow. Without that, existence might be too vast to even understand. So perhaps the universe is both timeless and made of time, depending on how you look at it. From outside, it's silent and still. From inside, it moves and breathes and unfolds. Both views, impossible as it seems, can be true at once. If that's the case, then you don't have to choose. You can live in time without being trapped by it. You can imagine the timeless whole without needing to leave the present. You can let the two ideas exist side by side, the way physics and philosophy so often do, each one pointing toward a universe that is far stranger and far quieter than any clock's ticking. After everything we've explored, the bending of time near black holes, the timeless quantum world, the block universe where every moment exists at once, it's tempting to think that understanding time will change how we live inside it. But the truth is simpler. You don't need to solve time. You only need to feel it. Because no matter how strange the universe may be, no matter how many theories point to time being an illusion, this moment is still here. You're breathing. Your heart is beating. The world in its quiet way is still unfolding around you. You don't have to reach back into the past or forward into the future to find something real. It's already here in the present, waiting for you. If time is a landscape, you don't have to see the entire map to walk the path in front of you. If every moment exists, you don't need to hold on to the ones that came before or rush toward the ones still ahead. They're already there, safe in the universe's structure. All you have to do is take the step that's in front of you now. And perhaps that's the point. Physics can strip away time's illusion, but it doesn't erase what it feels like to live in it. In fact, it can make each second feel even more precious, because if every moment is already eternal, then this one, the one you're in right now, isn't going anywhere. It's yours whether you notice it or not. So take a breath. Let yourself feel this instant's weight without trying to stretch it or shrink it or trap it in your hands. You don't need to fight time. You don't need to solve it. You only need to rest in it, the way the universe has been resting in every moment since the beginning, if there even was a beginning. All of this, the timelessness of physics, the endlessness of space, the quiet truth that every moment exists forever, leads to one simple conclusion. You don't have to understand time to be at peace with it. You only have to live in it. One breath, 1 second, one present moment at a time. And that's enough. Because even if the universe doesn't need time, you do. Not because it's real in the way you once thought, but because it gives you a way to move through the infinite without being overwhelmed by it. A way to simply exist here, now, while everything else, past and future alike, waits patiently, as it always has, and as it always will. So let it wait. You're already exactly where you need to be, and that's where we'll leave it for tonight. We've wandered through black holes and the quantum world, past the illusion of clocks, and into the idea that every moment, past, present, and future, might already exist, resting quietly in the universe's timeless structure. Whether time is an illusion or the very thing the universe is made of, it doesn't change this. You are here in this moment, and that is enough. You don't have to solve time. You don't have to hold on to it. All you need to do is let it carry you softly, one breath at a time. If this journey helped you drift a little deeper into thought or maybe even into sleep, I'm glad. And if you'd like to keep exploring these quiet corners of the universe with me, you can always join me again. There's always more to wonder about, and no rush to get there. So for now, close your eyes if you haven't already. Let the world outside grow quiet. Let this moment stretch slow and unhurried. Time will take care of itself. You just rest. Good night, and I'll see you in the next one.